So in this question here, we've got a triangle. Two sides are 16 centimetres and we've got one angle which is y. Now we're told that this triangle is an isosceles triangle. The area is 120 centimetres squared and all the angles are acute. So that's some good information to start with about the triangle. Now all we need to do is find the angle y. So that's what we're going to be as our target. So how are we going to go about doing that? Well, we know it's an isosceles triangle, so two sides are going to be the same. So we're given these two sides are 16, so therefore our isosceles triangle here is probably turned over on its side. So that will be what we call our base normally. So that's good. The total area is 120 centimetres squared. So what can we do with the area that we know, and we know that it's an isosceles triangle? Well, I know a formula for the area of a triangle, and that is area equals side A times side B times sine of an angle theta over 2. Now we can use this when we know our angles. Let's draw the triangle similar to this one. Actually, let's do that. So we've got a side here, side here, side here. Now here, for this formula to be valid, we'd have sides A and side B. They would have to be here. And sine theta would have to be this angle here. Now, in our diagram, we've got the angle on this side. So that formula is not going to work straight in like that with these bits of information. So let's work out what this angle is, and then hopefully we can work out what our angle y is. So let's plug that in and see what we get. So the area is 120. Sides A and sides B, which we are given, which are 16. So we've got 16 and 16. And sine of angle theta, let's put this one in here and call that theta. So sine of theta divided by 2. Well, that's good. We've got one variable and a load of numbers, so we can solve for that variable. So we can get this angle from that formula. So let's go with that. So now I've got 120 equals 16 times 16 is 256. Divided by 2 is 128. So I've got 128 sine theta. Okay, now get sine theta on its own, divide both sides by 128. So now I've got 120 over 128 equals sine theta. Okay, well, 120 divided by 128, let's divide through by 8 and find the inverse sine. So let's do that. So 8 into 120 go 15, 8 into 128 goes 16. So now bringing this on this side, theta equals the inverse sine, or the arc sine if you like, of 15 over 16. So now we've got a calculation for this angle here. Now plug that into our calculator, we'll get that theta equals 69.64 degrees. That's approximately, so that's an approximation. So to do decimal places, that's what we get. So we know that angle there. Now we know the property of an isosceles triangle. We know that this angle here is our theta, this angle is y. So therefore this angle here is also going to be equal to y. So let's use that property to try and solve for our angle y. Okay, now the sum of the angles in a triangle is 180. So 180 minus this angle will give us the total of these two angles. So 180 minus 69.64, that will give us two y angles. So let's go with that. 180 minus 69.64. So now I will have 110.36 equals 2y. Okay, now divide both sides by 2 and I've got my angle y. So then I've got 55.18 equals y. So as y is in degrees, I've got 55.18 degrees gives me my y degrees, my y angle. And that'd be a good place to stop.